So things on the mobile side are a little more complicated. The default flow still works the same way. The agent runs on the tethered host. It runs in Node.js. It connects out to the web server, and you can run a whole bunch of them in parallel. So when you run up the agent, you give it on the command line which device ID you want it to use. You can tether a whole bunch of phones all to the same tethered host and run a whole bunch of instances of the Node.js agent all on that same host. Each one will connect to the server independently. I run right about 10 instances right now. I think when I tried to plug in the 11th, it complained that it was out of USB IDs, even though there's supposed to be like 255 or something. Each phone must be using 10 or 20 of them. But anyway, your mileage may vary depending on what your tethered host is, but you should be able to run at least 10 phones per tethered host. And then it'll control the phones using ADB. It'll record all of the data. The phones will connect out to the sites depending on what connectivity you have set up for the phones themselves. So if you've got the phones running on actual 3G connections, they'll go over those 3G connections, and that's what you'll be measuring. Android works best. iOS can work. 4.4 KitKat or better is highly recommended. That's where you get the screen record, the good 60 frame per second video. Earlier versions of Android should work, although no guarantees because I don't do any dev work against them. They do need to be rooted. So Nexus and Moto phones tend to be the easiest because they support the unlocked bootloader from the factory, and rooting them is like a one-click step after you've unlocked the bootloader. I usually configure Google Play to auto-update Chrome. I have Chrome and Chrome Beta on the phones and just set it to auto-update. That way you're tracking whatever the current releases are out there. You can also do it manually if you want. I can see that with every 6-week updates on multiple phones, that can get rather tiresome quickly. When you configure it in developer mode, you're also going to, so all of these instructions are also on the documentation for installing the agent, but sort of the key things you're going to want to do are disable the screen lock in the security settings so that when you boot up the phone, it goes straight to the, I don't know, desktop or whatever you call it on the mobile phone, the splash screen. And the reason for that is when the phones go offline, and they will go offline, it's nice to be able to remote in and ADB reboot the phone and just have it automatically come back up and be available without having to have anyone actually touch the phones. And you do need to configure developer mode and enable the USB debugging. That's what makes it available for us to talk to. It also enables Chrome's remote communications, and disable the screen sleep so the screen stays on the whole time. I usually recommend turning the brightness down. Just uses less power, doesn't burn, that kind of thing. And depending on what your users are testing, you might want the phone set up where someone's not actually seeing them, just because you have no control over the porn loading on the phones at any point in time. Yes?
You mentioned Chrome and Chrome Beta. If, for example, you want to test either a different browser altogether, like Firefox or whatever, or a custom version of Chromium.
So the question was if you want to test a different browser other than Chrome or Chrome Beta. Firefox, no, because right now it requires talking to Chrome's remote debugging protocol, and unless something's changed, I don't think Firefox can speak that. As far as custom Chromium builds go, there's a couple of ways to do it. Probably ping me offline for the easier way, which is you can install an APK on the server and just have it automatically installed at runtime by the agents. Or if you install the APK on the phone, when you launch the Node agent, you can give it a command line that tells it what APK it needs to launch, and it'll launch it. At that point, you're locked into only using one browser, though. You could still have, yeah. So that phone would be stuck only testing that one custom APK, for example. You couldn't do Chrome, Chrome Beta, and a custom APK. You can do Chrome, Chrome Beta, and custom APKs if you use the dynamic install. Depends on what kind of usefulness you want to get out of your phones, for example. So like testing Chrome patches on the public instance, we do it with the custom APK method. So we have the Chrome and Chrome Beta always available, and then at any point in time, it might also be installing custom Chrome builds if I'm doing perf testing for loader changes and things like that. On iOS, it will technically work. Odds are you're going to have to get your hands a little dirty because it's still really early. You do need to jailbreak the phones, which is kind of painful. You need to install and configure the iOS WebKit debug proxy. It's on GitHub. This is also a link to it. It's best if before you run the node agent that you actually try remote debugging Safari on the phone from Chrome on your desktop. That'll tell you you've got everything actually configured so that we can talk over the dev tools, and you've got all of the debug proxy and stuff configured correctly. And then you also need to build the OpenURL IPA with your own OS X dev keys, mostly because you can only launch things on iOS that you built and that are signed with the same dev keys that you have. So all of these are things that are on my list to try and find solutions around to make it easier to deploy. But it is technically possible. You won't get video, but you will get screenshots, waterfalls, and that kind of thing. And it should work pretty much with any version of iOS. I don't think we've tried iOS 8 yet. On the tethered host itself, we touched on this a little bit. Linux or Windows, Mac may work as well. It really just needs Node.js and ImageMagick for resizing the thumbnails. And there's a batch file or a .sh file that you launch, and on the command line you give it all of the parameters that it needs. The device ID that it's going to be running the testing with, what the server is, and what the location ID is that you're going to be using. If you're running on Windows, there's a separate project I have, ADB Watch, which is basically just a watchdog on ADB, and if ADB hangs, it'll kill it and restart it. I use it on the public instance, so I don't have to constantly manage the phones, and they can usually run for about a month or so on their own before I even have to reboot or do anything with them. As far as the network connectivity goes, native connectivity over the phone tends to be the simplest configs. The mobile agents in general have much more complicated than desktop. Desktop, everything's self-contained. For the mobile agents, you have to also figure out what the network path is that you want to test out. So in the case of actually using a cell network, 3G or whatever, the agents do all of the talking to the web server. So the results, the test jobs, none of that come through the phone, and those will go through whatever connectivity the test agents have. The phone will connect out to the sites being tested on whatever connectivity, so in this case over the cell network, and then the results get pushed back up to the server. You can tether the phones, reverse tether the phones through the tethered host, through the agent, in which case it'll do all of its networking over USB, and then it'll go out to the sites being tested. So the main issue with testing on actual carrier networks is they're really noisy. If you want consistent results, yes, it's the real world, but you're going to get results that are kind of all over the place depending on the cell capacity and all sorts of other random things going on the networks. It's good to know sort of what your performance is in the real world, but when you're actually doing the testing, odds are you're going to want to use a more controlled environment. You can also run IPFW dummynet on the tethered host if you want to do traffic shaping for the reverse tethered USB connections. This is actually the architecture we use on the public instance right now, mostly because it was easier to deploy than doing the reverse tethering on the phones. The phones are set up to do Wi-Fi through an access point. The access point then goes through a bridge that does the traffic shaping and then out to the sites that are being tested. The Node.js agent technically knows how to talk to a bridge doing the traffic shaping and configure it. I just haven't set that up on the public instance yet. So right now they're all going through a fixed config. So there's a single 3G profile if you run mobile tests on the public agent. And there's just a fixed config on the dummynet bridge, the IPFW bridge. It's a little more complicated if you've got a highly dense deployment. You have to be a little careful. Your Wi-Fi access points, channels, all that kind of stuff, you start running out of, if you're running 50 phones, for example, you only have 3 Wi-Fi channels that don't overlap. If you set like the access points to lowest power, put them in a 1U rack, like metal enclosure, you can sort of try and constrain things a little bit. But at that point, you might need to start doing the reverse tethering and going over the actual USB connection just because of Wi-Fi frequencies. If you do the reverse tethered over USB, one thing to watch out for is the command and control as well as the test data are both going over the same USB connection. If you've got 10 phones tethered to the same host, just make sure you're not running out of USB capacity and impacting your test results by the the command and control data, like transferring videos back and forth from the agents. Let's see. Just want to see really quick. Ooh, EC2 agent still isn't up. Well, it claims it's up. Maybe I did something wrong with the config. Oh, you know what I didn't do? So I copied all the files up to the server, but we didn't actually set any of them up. So we'll go into settings. So by default, the configs have .sample versions of all of the settings. So settings.ini.sample, for example. Just change that to settings.ini. Here we go. So I got a permission denied, so I'm just going to do completely unsafe things and chmod it to 777. So settings and locations.ini are really the only two that you need to touch. And this one. Okay, so I just had a predefined, I have a locations.ini that I had set up beforehand that has a US East location as well as a mobile in case we have time. I've got a phone, we can try bringing up a mobile location as well, but now let's see if that works better. Oh, yes. So we now have test location connecting for US East. Nexus 4 is not connecting. There's also no agents connecting for rendering video. Right now, video requires URL blast to render, so you need at least sort of one legacy agent running. We're working on moving the video rendering to the server. It's only if you get a film stripping, you need to create a side-by-side video is what the video rendering is used for. WebPagetest. So now we have the US East Chrome location that's running on the EC2 agents. Ooh. Oh, I know, I forgot to. There's also a connectivity.ini that defines the connectivity types. So you can pre-configure all sorts of different connectivity types if you want on the server. WebPagetest ships with a default set, the cable, DSL, stuff that you see on the public instance, but you're welcome to predefine your own. And video, first view, okay. So we'll let that run. So as far as the queues go, there are priority queues. The UI, by default, anything submitted through the UI gets the highest priority because you sort of assume someone's waiting for results. Anything that comes in through the API gets a mid-level, it's priority 5, picked completely randomly. There's also a bulk test UI that you get on private instances that you don't get on the public instance. Where over here in the settings tab, there's a bulk testing where you can paste in a whole bunch of URLs or upload an URL file and test like thousands of pages and get aggregate results back. Those default to going in at a priority level of 4, so slightly above API level because you assume someone's actually waiting for the results, but lower than the level where people are submitting one-off tests. And people can submit if you're using the API, you can define what priority level you want to use. When you set up API keys, and we'll get to those in just a second, you can also force a given key to a certain priority level. If someone's abusing the system or going to be doing a lot of bulk testing, and you just want to force them down to, you can use the idle cycles on my system, for example, but you can't run and compete with people that are doing more active testing or lower volumes of testing. And that's pretty much what you're going to get is if you deploy a private instance install and open it up to the world, even inside of your company, maybe you'll get a lot of different users, maybe you won't, but the users that you get testing it, sort of, if they don't have any cost to running the test, there's no incentive for them not to run everything in the world through it. So you'll get maybe someone running 10 million tests through it because they can, because they thought it would be, hey, what's it going to look like if I run the whole HTTP archive suite through our internal instance, for example. And all of a sudden, all of your testing infrastructure is backlogged running their tests, and no one else can run any tests. So that's what API keys are used for. So there's a keys.ini file in the settings, and by default, they're disabled. Anyone can submit any tests through the API, and there's no thresholds or anything like that. The keys.ini lets you specify, first off, if it's present, then API keys are going to be required for anyone submitting tests through the API. And they need to have a key defined in the file, otherwise they're going to get an error back. Like if you use the public instance, it has just an instance of this. It has a long keys.ini that has everyone's API keys in it. And they'll get an error back saying, sorry, API keys required. And then it'll also constrain. So the two that you absolutely have to have, let me see. Right up at the beginning, at the top of the file, is the key that the server is going to use for its own UI. So that one, as long as you want people to be able to submit tests through the UI, you need to define that one. And I usually set the limit to 0, which means as many tests as people want. Because otherwise, anyone who submits a test through the UI is going to get an API key problem. And the key, so the secret can be any random number. The key needs to be defined in its own section as well. And that's the key that the server will actually use for its own UI tests. Anything that you define beyond that are API keys that you hand out to people. You can give it a contact. Really, the only two things that are needed are the contact and the limit. The contact is the email address or whatever you want to store about how do you reach back to that person if you're seeing problems with their key, and how many tests you're going to let them run. And these tests are actually page loads. So if they run 20 URLs, first view and repeat view, that actually ends up being 40 page loads. And that's sort of the way to prevent like one API call running 200 tests and counting that equivalently to someone running 200 small tests.
Would this affect scripted tests?
Would this affect scripted tests? How are the tests scripted?
If I go to 5 pages, then I record one.
So if you go to 5 pages and then record one, right now, no. It treats each, right now it just, an entire script counts as one page load. There is the facility internally to the code to know about how many navigations you do to progress to that final one that you're trying to measure, but that doesn't get counted right now. You can also force, if this is missing, they'll get the default priority level of 5, and they can provide their own requested priority level on the API when they submit. If you force a priority on the API key, they can no longer request one, and they get forced to whatever priority you set. And then, yeah, sort of the minimal config is just the contact info and the limit on how many runs they're allowed. And then just fill out the ini file as you hand out keys. Right now, it's all manual for me as well. Thinking about maybe adding some UI, but I also don't want to make it too low friction for people to get keys. It's kind of like, well, what are you doing with it? Make sure you're talking to other people in your organization. Or do you know about this other stuff we've got going on kind of stuff? So it's always good to have that touch point with your users that are using the API. Firewalls, especially if you're running a private instance. This is where things get interesting. Question? Can you disable the UI if you only want people to submit tests through the API? Yes. I think I have that covered here in a second, but there's in settings.ini, there's a headless equals 1 that you can provide, which turns off all of the UI, doesn't let UI tests, and requires API keys for everything. That's actually how we have the HTTP archive runs on top of an HTTP on top of a WebPagetest instance, a private instance, that is configured to run headless. So it'll run the HTTP archive tests, but you can't like run arbitrary tests through it. So firewalls create an interesting challenge in that the agents all connect into the server. So if you're running test agents outside of your firewall, your server needs to be reachable from outside of your firewall, which gets to be problematic if you're storing all of your results on that same server. But that is one way to configure it. You can put your server outside of the firewall or poke firewall holes, either way. And then the agents themselves can all, both inside of the firewall and outside of the firewall, can talk to the server as well as the test sites. You can lock the server down a little bit. Make sure you use keys for all of your test locations. The agents only need to talk to the work directory, so that's the only one you sort of have to need open access to from the public internet, or at least from where the test agents are. You can either have firewall rules or auth access to the rest of the UI, like HTTP access or HT access rules for the rest of the UI to require people to log in to see the results and that kind of stuff if you want to run the server outside of the firewall. The other thing you can do, and is probably the better way to do it, WebPagetest supports a concept of relay servers, where you can have a completely headless server that your WebPagetest instance forwards test requests to. It'll run the test, and then the results get downloaded back to your test agent. So it's a completely headless proxy for running tests, if you would. And that way, all of your test results can stay inside of your firewall. The public agents only need to be able to talk to the relay server, and all of the connections are still outbound through your firewall. So your WebPagetest server always connects out to the relay server, and it pulls it for results. So no firewall holes need to be poked anywhere. And this actually works even for non-firewall use cases. You can, for example, configure your private instance to relay to the public WebPagetest instance and use your API key, for example, if you want to make a couple of public locations available to your internal users. One of the things I've actually been hoping someone would release or make available is a commercial service. Here's our test infrastructure. Here's a relay server. We'll charge you by the test or whatever. So you could relay your own location against their public infrastructure, and you get charged for running tests against their agents. But that's sort of what it was built for. On the relay server, you still need to configure the locations as you would for an internal instance, and configure API keys because you want to make sure you're the only one submitting tests to. This is the headless equals 1 setting for making it so the UI doesn't work. And then all of the results get pulled back to the internal instance. You can never view any of the results out on the public instance. It just runs the test and downloads the results back. They're never available. There's like no URL you can use that would make those visible on the external instance. On the internal instance that's doing the relaying out, you would set up the locations like you normally would. You would add a couple of location-specific relay information. It's mostly just, let's see, the server you're connecting to, the API key, and the equivalent location ID for your internal location on the public one. So your location IDs don't need to match. You can use whatever you want internally for the ID. Like you could call this public WebPagetest Dulles or something for your internal ID. And on the relay location, it would be Dulles. The browser list does need to match, though, because that just gets sent with the test information. And the way you configure these, since you configure it on a per location basis, you can relay to a whole bunch of different servers as well. If you get really complicated with your mesh config, you can relay to the public instance for some public tests, for your own public relay agent for your own public tests, and for this fictional commercial service that someone's going to set up, right, to do testing on demand, or multiples even. As far as the results storage, so we talked a little bit earlier about the directory tree where the results get stored. If you want to get rid of old tests, well, it's all hierarchical. You can delete an entire year's worth of tests just by deleting the directory for that year. Same thing for by month, by day. Probably a cleaner way to do it is test archiving. So the WebPagetest UI, if a test isn't available locally, there's a couple of configs that you can do in settings.ini for archiving. It can archive to S3 or to a local path. But if a test isn't available locally, when it goes to get the test result, it'll look at the archive config and go, hey, let me see if that test is in the archive, and if so, restore it. So archive tests are completely transparent to the end user, and whenever they're accessed, they get pulled back out of archive and made available. And so both on the HTTP archive instance and the public web page test instance, we use archiving heavily. Like the HTTP archive, the results are never kept on the server. When you go look at a result for an individual test, it always pulls it back down from cloud storage. For web page test, after a day, we archive the tests off to magnetic storage. By default, they run on SSDs for the live results. We archive them off after a day to magnetic, and then after a week, they go a second level of archiving off to a NAS, where we sort of keep them forever. And we have tests going all the way back to 2008. So I think we've got about 14 terabyte of tests right now. Although the HTTP archive is easily outpacing that on a per month, how much data it accumulates. So there's some settings. There's a settings.ini.sample that's part of the GitHub project that has sort of the configs for both of them. You can define how long it waits before going off to storing them on archive. And the main thing that you get when you do the local path, it zips up an entire directory. So now all of a sudden you've got one file for each test result. If you're running out of nodes, inodes, for example, is not an uncommon thing to run out of for the test results. Archiving them even to the same local disk will buy you a whole bunch of inodes back. And then the second tier, an entire day's worth of tests all get zipped up into a single archive. So you've got one zip file per day on the second tier of archive. As far as S3 goes, it doesn't actually have to technically be S3. Anything that can talk S3's protocol for uploading files. You give it a server, a key, a secret, and a bucket where you want to store it. And then as far as the config goes, you can also provide an URL. So if the S3 URL isn't provided, it's going to use the S3 protocol to try and download the results back. However, if an URL is provided, it'll try and fetch it over HTTP. So if the service you're using can talk S3 for uploading files to it, but not for fetching for whatever reason, you can use that route. That's what we do for the HTTP archive, for example, is it's using the Internet Archive storage, which is S3-like, but not actually S3. And each test basically just gets uploaded as a file with a zip to the bucket. And however many you archive is how big your bucket's going to get. It doesn't do any hashing or directory trees or anything like that. Yes? Pardon me? How do you archive on the local server? So in settings.ini, there's an archive dir that you can set up, which basically just tells it where do you want it to copy things to, and how long you want it to wait before it does that. The one thing that you have to do, so once you define the archive settings, as soon as tests complete, they'll get archived. The archived copy will be written immediately, and then you just need something that'll prune the local versions of it. There's in the CLI directory of the install, there's an archive.php script that you need to put in cron, and I run it every 15 minutes, for example. And it'll just go through your directory tree and look for anything that needs either hasn't been archived or has been archived and just hasn't been touched in however many days, and it'll prune your tree for you. So that's you need to do both pieces, both the config and the cron job, to make sure it keeps the directory tree clean. And you're also welcome to completely replace it with your own. WebPagetest itself, all it cares about is being able to retrieve the file. If you want to change the logic in the archive script, it doesn't depend on any of the other code. It just walks the directory tree, checks against the number of days since it's expired, and deletes files. So it's nothing terribly fancy. Will it archive the videos? No. So right now, the videos, they're written to a different directory tree. And right now, the way I have it running on the public instance, at least, is the videos are directly symlinked to the magnetic storage. Although, yes, adding support for archiving the videos is on the list. It'll archive the film strips, but not the side-by-side video, the rendered videos. Yeah, so we already sort of showed off the bulk testing. You can also disable if you're running a private instance and you don't want people to be able to do hundreds of URLs in the bulk UI. There's a no bulk equals 1 setting that you can disable the bulk UI testing. The one thing to know when you're doing the bulk testing, you can do both a script and bulk testing at the same time and run a script against a full set of URLs. The script supports some substitution parameters in them. You can use URL, or they're all enclosed in percent signs, but URL will, as it goes through the list of the bulk URLs, anywhere that URL shows up in the script, it will replace it with the actual URL in the bulk test. Same thing for host. It'll just take the host name out of the URL. And host R is a special case where it'll look up the host name, follow any redirects, and use that final redirected host name in the script instead. And so that way you can use it if you want to fake DNS settings for the domain you're testing and rewrite it to point to like a dev system. You can do like set DNS %host and then the actual dev server that you want to redirect it to if you wanted to do it on a per site basis. Otherwise, you could just use star in their scripts as well. But it will do substitution in the scripts in case you want to do fancier scripts with bulk testing. So API, I think we've already covered that. If anyone has questions about the API, probably ping me afterwards. But pretty much anything you can do in the UI, you can do through the API. And then there's a whole bunch of tools that are built on top of the API tied to the API keys. And it's pretty much, it's all the same way. Through runtest PHP, you pass the various parameters, and you get either JSON or XML back with the information about where the test results are. There's a API wrapper written for Node that Marcel Durand did. It's an NPM, just install WebPagetest. And it can both run one-off tests through the command line. It will also do continuous integration with Jenkins, Travis, and a whole bunch of other things. It'll spit out tap results so that you can make it as part of your build process. Yep. And so Marcel's got a whole link to how to do the CI integration. Oh, and Jenkins as well. There's also, Tim Kadlec has a Grunt plugin called Perf Budget that runs against the API. And this is where, when you're running a private instance, is where you really start to benefit from the continuous integration testing and make it part of your build process. Because you can do, like on every commit, you can run perf tests against the instance. And so this will give, I believe Tim's Grunt task will let you set a performance budget, and if it exceeds that, you'll start getting alerts. Sort of on the more extreme or the more integration side, a recent addition, maybe a couple of months ago, WebPagetest can also log all of the test results as they come in. So not the actual tests themselves, but for every test that gets run, as the results come in, it can spit out a JSON log line for the actual test results of that test. Both the page level stats on load time, speed index, all that kind of stuff, as well as the raw request data, every single request that page loaded, the ads, the JavaScript, and whatever else. The full waterfall can all get written to a log file so that you can integrate it with Splunk, Logster, sort of any of your other server logs processing, feed it into Graphite, build a dashboard, that kind of stuff, and sort of do it automatically. And pretty much, I think everything that's available through the API gets written to the log. So the breakdown by content type, file size, all that kind of stuff gets written out so you can graph it as part of your normal. So if you have a bunch of tooling set up for your ops tooling, for your access logs parsing, that kind of stuff, this is a good way to integrate your synthetic tests in with that. The other thing that's built in that I don't think I've told anybody about yet is WebPagetest supports its own benchmarking. The configuration is really hideous. Couldn't follow that link. So right now, to configure it, you actually have to write a PHP file that defines the configs, but you define the URL lists that you want tested, what locations you want compared, and the various different test parameters. And then there we go. it will trend them for you over time, give you, sort of the nice pretty graphs. So at the main level, it'll show you speed index, but hang on, I'll show down to the more interesting benchmark. Here, where we compare the browsers against each other. And then you can drill down, and this will have all of the different metrics, load time, speed index, time to first byte. By default, it shows median. You can do various different percentiles, averages. And then if you want to drill down, you can click on one of those, and you can get to a full scatter plot for all of the URLs across all of the different browsers. And then from there, if you want, you can drill down further, like if this one, for example, one showed faster, you can drill down to a film strip comparison of them. So if you're trending like you against your competitors over time, for example, and if you want to see why you got slower, or against a reference build of your site, it's sort of a cheap way to do the benchmarking UI, or a monitoring UI, if you would. It's not integrated with any alerting or anything fancy, but it's there if you want to use it. And then it'll take you directly to a film strip. So it's like fully integrated for drill down. Steve. Is that available on the public instance? And if so, how would you use it? No, and you wouldn't. So it's available in that I have a couple of benchmarks that I run just for demo purposes, where I have like a content site, Yahoo versus MSN versus AOL or something like that, and the browsers against each other, just sort of to demonstrate how you would use a benchmark. But definitely, the public web page test instance is not meant to be a monitoring tool, and not meant to compete against monitoring tools. It's much more for one-off tests. So I really tried to discourage any ongoing, unless you're doing small volumes through the API and building your own thing, I try to discourage monitoring against the public instance. By all means, if you want to deploy your own private instance, and after here, everyone's going to, you can set up your own benchmarks to run. The other thing you can do is this will automatically kick off the cron jobs to run the tests. But if you also have your logging integrated with Graphite or whatever, you can have the test results spit out to something else. You don't have to necessarily consume them in the WebPageTest UI. So as far as monitoring, if you've got an instance and you want to make sure it stays up running, so there's a cron job that runs, I think it runs automatically. If not, it's under work. It's checklocations.php, which will send emails out for any locations that haven't connected in the last hour. Or if a certain number of devices has dropped down below the configured number of devices, it'll send you an alert. There's also a couple of things in the UI that you can take a look at. There's get locations and get testers, which will dump a list of the test locations and how long their queues are. Probably best if I just show you. I'm just going to do it incognito so I don't accidentally leak some information I shouldn't. So this is the location check. It basically tells you, let's see if I can zoom in, how many testers are not doing any work, the total number of tests, and then in each priority queue, how many tests are queued up. And it highlights any that are doing work, get highlighted yellow. So if it's not highlighted at all, it's just sitting there idle waiting for stuff. So here you can see Dulles IE 10 and 11. There's a bunch of tests running at priority 8. That's probably someone with an API key that I forced to a low priority so you can sort of use idle cycles. Anything that shows up as red is a location that's offline and not polling or connecting in. But you can sort of spot check and see, hey, I have 10,000 tests waiting for this location. What happened? There's also get testers. I think there's an HTML version of this as well. which you can see individual test agents, and it gives you a little more information. The main things I look for here is to see if a given test location is offline. And I spend more time looking at the mobile devices than others, because I know I have 5 Moto devices, and they're named Moto G1 through 5. And the other thing to watch out for, I just added reporting for this recently, is the error rate, how often a given test location is failing, in case it's running tests but not successfully. And that's sort of feeding into, right now if a mobile agent goes into 100% error rate, for example, odds are it needs to reboot. It's running tests for whatever reason. It thinks it's running tests, but it's not running them successfully. So as we discover more and more of these things, it's sort of feeding back into things we need to do for the mobile agents themselves to self-recover. So for example, from that, what we're going to do is, hey, if we start seeing these class of errors, and maybe we see it more than a couple of times, just go ahead and reboot the phone, because we know how to do that. And then the other thing to check is there's this check IPs call where you can see for the various different IP addresses running tests inbound across the last however many days, how many tests have they run. And it's sort of on the non-API key side of things, it's a way to tell if someone's automating your UI through, it's not uncommon for someone to like use Selenium to drive your UI as a way around using API keys, for example. And they'll just submit like 10,000 tests or something like that. And you go and see, hey, like I apparently need to figure out whoever 184.51.154.10 is, because they submitted 5,000 tests. So I'll go in, and you can block by IP address or block URL. So I'll go in the test history, look for that IP address, see what they're looking, and see if it looks like they're running automated testing, and if so, I'll block it. And usually, more often than not, when you block an IP address, you'll get an email within a day or two and say, hey, we're blocked, can you unblock us? And I'll go, well, you were running an awful lot of tests, could you not do that? And they'll do it nicely. Sometimes you won't get pinged at all, and they'll just stop running tests. But yeah, I do have to check this every couple of days or every week or so just for keep abuse under control. I don't know, in a private instance, you may or may not run into that. Although running our private instance, I've also run into cases where we do have, someone will submit the 10,000 tests, and it's like, could you not do that, please? I think that's everything I had. The main thing, there's a book coming out that on the using side, it'll also cover running private instances. I'm not writing it, but the 3 guys that are writing it are longtime users. Marcel, who created most of the API wrappers, Rick Viscomi, who does a whole lot of YouTube testing with it, and Andy Davies, who's also one of the huge users and API users. As Steve mentioned, please, not just for me, but for all of the presenters, provide feedback. What worked for you? What didn't work for you? Did you fall asleep? More dancing monkeys. Did you feel like you got your value out of coming to this session? And if not, why? What would you like to see more of, that kind of stuff? And thanks.